So my name is Claudia and this is my arc length project for trimester 3 for AP Calculus. So to give a brief introduction about how I chose my path, this path is roughly 5 minutes away from my house. Usually when I go running, I will choose this path. Or as you can see in this little picture, this track over here, I'll sometimes run on that. But to make things a little more interesting, I chose to calculate how long this path is. Again, I will usually run this several times, but anyways, I never really knew how long, like in length, I would be running. So that is the objective of this project. So after I found my desired path on Google Maps, I traced out the border of the field in the correct class layer with the Draw the Line tool featured on Google Maps. I named this path Claudia's Path, and then I also added a marker to designate this path. So this is my path, this picture right here. The objective of my project is to find exactly how long this path is. So this path length consists of 5 straight segments and only one curve. So here's one straight line, here's another, this is the third, this little one's the fourth, fifth, and then this is my one curve, which I will be finding the length of. Um, So these are each of the segment measures. So segment 1 right here is 422 feet. Segment 2 is 616. Segment 3 is 567. Segment 4, this little segment right here, is 43 feet. And the last segment is 319 feet. And again, this curve is what I will be trying to find. So this is my arc, a little closer picture. I determined 5 coordinate points using the measurement tool on Google Maps, and then I'll be using the arc length formula to find the length of this parabola. So the coordinates that I found were, I acted for this to be 0, 0. So this is my XY coordinates right here. We have 0, 0, 87, negative 37, 109, negative 43, 147, negative 50, 185, negative 43, 221, negative 37, and 282 and 0. And again, this is just the graph that was drawn out using the app that I used. This is the actual parabola, and then there's the line of best fit, and I will talk about that equation in the next slide. So using a graph app, I'm not really sure what the name of it was, but I used that to plot the 5 points that I mentioned previously of my curved length, and then I found the parabola of best fit. So here is the parabola itself. And then the parabola of best fit is measured right here. And so the equation that the app gave me is this one right here. And then using this, the derivative of this, I will use the arc length formula. So again, the equation is 0.0233819 x squared minus 0.684221x plus 1.4785. And so the derivative of that is 0.047638x minus 0.68421. And so we know that the arc length formula is the integral from a to b, the square root of 1 plus the derivative of the function squared. And so in my case, this will be the integral from 0 to 282. And then you just plug in what you have. And this formula gave me the length 301.95 feet to be my curved length. And that seems like a reasonable number because if we go back, we can see that, where is this? We can see that this length is 319, and so because this is a curved, it should be somewhat around there. And it is, it's 301. So, to double check to make sure that this number kind of makes sense, I go back to my picture. And then to calculate the total length of my path, I just add all the segments up. So 412 plus 616 plus 567 plus 43 plus 319 plus 301.95, which is what I just found. You get a total of 2,258.95 feet. And now, in order to compare this to the Google Map distance that it gave me, I have to convert it to miles. So 2,258.95 feet is roughly 0.428 miles, and the Google Maps distance gave me 0.430 miles, so I was only 0.002 off, which is pretty good estimate. I was fairly close. So in conclusion, if I run this path exactly once, I will be running 2,258.9 feet, which is approximately 0.430 miles. So thanks to this project, now I know exactly the length of my run, and so I can run an accordingly amount of laps according to the amount of miles I want to do per day or per run. So thank you for watching.